Hello everyone, welcome to this workshop on an introduction to animation. My name is Yang. I'll be representing the Ryzen Gamerkers Union to bring you this workshop. And the goal of this workshop is to provide you with the information you need to understand the basic of what animation is, the different types of animation, the importance of animations in video games, what are the differences between 2D and 3D animations, as well as some principles of animation and how to do digital keyframe animation, which is the most common technique used in game development today. So, first of all, what is animation? Well, animation, the word animation comes from the Latin word animatio, which means a bestowing of life. But in all seriousness, animation is trivial, like definition is just a simulation of movement by combining a series of still images. So if you look at the image on the left, you can see that there are 6 images of a red ball bouncing, and on the right we see that when we play these images one after another and loop them, we see that we have a little animation of a ball bouncing. So I have this quote from Brad Bird. He said that animation is about creating the illusion of life, and you can't create it if you don't have one. So, well, that's his definition on it. Animation is about the creation, creating the illusion of life. And by the way, if you don't know him, Brad Bird is actually the director of some really amazing Pixar movies like The Incredibles or Ratatouille, one of my favorites. So let's talk about some different types of animation. So the first one that I'm showing you here is hand-drawn animation or traditional animation. Was how animation was made back in the days, like in the 40s, 60s, like some classic Disney movies were made using hand-drawn animation, which is a lot of work because each individual frame has to be drawn by an artist, and then you have to play these frames one after another. Now, to speed up the process, they actually use multiple layers to show the animation. So if you look at the animation that I have here, so the trees in the background, the ground, they're not moving. So they're actually on the background layer, and they don't have to be redrawn every frame. Only the action of the cat and the dog has to be redrawn every frame. So that speeds up the process a lot. And of course, it is the simplest form of animation because it was how animation was invented in the first place. And there is a very cool trick used by Disney back in the days to sort of simulate 3D depth because, well, animations are drawn on a 2D surface, but they layer different panels of glass on top of another and then put a camera on top of those glass panels and then manipulate that camera to simulate a sort of 3D effects, as you can see here. It's a pretty cool trick. And as we enter the digital age, animation also evolves, and now we have vector-based animation, and this technique can actually be used for both 2D and 3D animation. So in this technique, so the characters are built on a system of bones and controls. So we call this system a rig, and it is like a digital puppet that you can manipulate. So the arm, the leg, the body, etc. And to animate these characters, rigs, we can use some programs such as Adobe Animate, After Effects, or Blender. And this animation here shows how the animation process works. So we see a rig with this character, and then when we manipulate a different part of him, we can animate him. And there's also stop motion animation. So in this technique, the animator will physically have to manipulate the real world objects and then capture pictures of them to play these pictures one after another to simulate the motion. So as you can see in the on the image on the left, lower right, lower right, the animator manipulate this dragon and then take pictures of them, so that the result is the upper right animation, which is pretty cool. And finally, we have keyframe animation. Again, this technique can be applied to 2D and 3D animation. This is a more complex technique because in this technique, we define the start and the end states of a property, and we call these start and end state a keyframe. So think of them like as an anchor point for the animation. And then whatever program that you're using to animate will smartly interpolate between these keyframes of specific properties. So if you look at this animation on the right, so when the character is on the right here, that is one keyframe. When the character is on the left here, that is another keyframe. And then the movement from the right to the left and vice versa is generated by the program itself. And this is the most commonly used technique in video games today. And of course, there are a lot more kinds of animation that people have used to create really amazing results. So the picture that you see on the left here is actually rotoscoping, which is when if they capture a video of some action and then they draw on top of that video to create the animation. And on the right here, we can see motion capture, which is gaining more and more popularity. It is used for like when you want to capture a very detailed animation that you don't want to spend a lot of time like animating manually. And so why are animations important in video game? Well, first of all, back in the day, when you play Mario or Donkey Kong, the animation is just a part of the enhancements of the experience. So if you can take out the animation, the game will still work. Well, it would be worse, but it works. So it enhances the experience in a very special way. And it can also convey information in a very unique way in video games as well. So if you look at the animation on the left here, like the animation of Superman and Batman, what can you tell about them through their animation? So that shows you that the information that animation tells you is a very unique way. And animation also provide context to the game world. So if you ever played Bloodborne, on the right here, you see if an enemy is winding up for an attack, well, you know that enemy is about to attack, and it's time to get out of the way, and you can tell that through their body language, their animation. And in the early days of video games, animations were generally pretty simple. Each individual frame is drawn by an artist, and they just play the frames one after another, just like traditional animation, except it's a lot more pixelated due to the hardware limitation of the time. And for a very long time, this is how animations are done. As technology advances, we can put more frames in an animation. We can put more pixels in a frame, but the technique generally stays the same. But there were some pretty innovative games in these times as well. So as you can see here is Mortal Kombat. They actually capture videos of real life actors performing the fighting moves, and then they export these videos into a series of images, and then they play these images one after another to get the animation. And in another example is Donkey Kong Country. This is quite similar to Mortal Kombat, except instead of using a real life monkey, they model a 3D gorilla or 3D Donkey Kong, and that 3D model consists of even textures, shading, lighting, and everything. And then they animate that 3D model and capture 2D images of that 3D model and then play them one after another to create the animation. Another example is Prince of Persia. As you can see, the animation looks very, very smooth and very, very natural, but it's actually hand-drawn animation. Each frame is drawn by an artist, but they actually use rotoscoping, something that I talked about earlier, where they capture video of an actor performing these moves, and then they draw the frames on top of that video to sort of base their animation on the video of the real life actor. So it looks very, very natural. And then 3D games arrive in the scene. And then, well, they're going to need a new technique for animating game objects. So they came up with animation rigging and keyframing. So basically, think of a 3D model as something that is made of different parts of, say, a character body. So if you look at Mario here, he's made up of the head, the body, the arms, the hat, and the leg. This can be one mesh or multiple meshes, and then they just define the rig and then keyframe animate this rig. And modern 2D games also adopt this technique for their animation. So as you can see on the right, this character is made up of the head, the body, the arms, legs, and then we just animate these different parts to create an animation. And a more modern technique that was invented is motion capture. This is when some of the animation that we want to create are a lot more complex. So maybe it's like a martial art move or a very subtle facial expression. So we want to capture the real life actors and then base our animation on these actors. So it's called motion capture. And so what are the differences between 2D and 3D animation? Well, technically, 3D animation is 2D animation, but everything has to be digitally generated. So every single frame has to be generated digitally. Whereas in 2D animation, you can draw each frame manually and then play the frames one after another. Or, of course, you can generate digitally using rigging and keyframing. But in 3D, you cannot draw 3D on a 2D surface, so it has to be a digital generator. So let's say you can put together a basic animation in Python or in Unity or in Blender, but it doesn't look very good. How can you improve that? Well, let me introduce you to the 12 principles of animation. So I list all 12 of them here. I'm not going to go over all of them for the sake of time. There is very good video that I recommend you to watch to get all the details of the 12 principles. But let's go over a few of them. So the first one I want to talk about is squash and stretch. So if you look at the animation on the left, it's a ball bouncing. And it is an animation, I can tell you that, but it doesn't look very exciting. Now if you look at the animation on the right, you can see that as the ball bounces around, its width, its height, its shapes, changes as it hits the different surfaces. And that's what when a ball bounces, it should look like, right? So that is called squash and stretch. It shows the reaction of when an object hits something. And another principle that I want to talk about is anticipation. So if you look at the animation on the left of this man jumping, he just jumps. There's no build up, no anticipation, no nothing. He just jumps. Whereas if you look at the animation on the right, so it's a frog leaping, very similar, but before he actually performed the leap, he, there's a bit of a build up for that leap. So as you can see, a few frames here where he built up for that leap, and it showed and it set the expectations for the animation and improve it. And another principle that I want to talk about is exaggeration. So if you look at the animation on the left, it's actually pretty good. Like there's anticipation before the slap, and when the left guy get hit, his head actually squashes a little. So that's also squash and stretch. So it is actually a pretty good animation, but we can make it even better with exaggeration. So if you look at the animation on the right, is absolutely crazy, and realistically, no one in real life can perform something like that. But that's what animations are for. It's not real life. So it is generally a good rule to exaggerate all of the movement to make the animation more expressive. So you have all this knowledge regarding animation and 12 principles and whatnot, but how do you actually use them in a video game? Well, there's a simple framework for animations called IISF, which stands for Identify, Inspire, Sketch, and Fill. So in the first step, you identify what do you want to animate. What's the action you want to perform? What is the entity? What is the character that the animation will be applied to? And what is the context of the animation? And then inspire, you can go online, find some sample work of someone that have done that and be inspired by them. And sketch, basically, perform a very rough work of the timeline of each frames of the animation to show the action. And then in the final step, fill, you use the 12 principles that I talked about to improve and fill in all the movement and improve the animation further. So you might have heard of Spritesheets if you ever make a 2D game before, or if not, it's basically a collection of frames in one single image. right? So suppose, say you're making a game with this 2D bouncing ball. Well, you need to draw 6 frames, right? All 6 of them. But you don't want to keep track of all of them at once. Well, Spritesheet is a good way to group all of these frames into one file and then just keep track of that one file. And yeah, so that is a good way to organize all of your files. Don't get lost in them. And it's very easy to swap out animations one for another if you want to redraw, say, 1 frame or 1 or 2 frames. And of course, well, you have less file to manage. Yeah, have less files to manage. Your computer will be happier essentially. And but when you play the animation, you have to split this one single image into 6 different frames and then play them one after another. This is actually supported by a lot of game frameworks and game engines. In Unity, we have a tool for exactly this, splitting a spreadsheet into different frames that can be used in an animation. So some of the resources that I really recommend you check out if you want to learn more about animation. You can check out the slides that we will set up for the link to these resources. So to sum everything up, animations, so it is a sequence of images that is generated using multiple techniques that can be done in multiple techniques. And these images will simulate movement. And animation have always been, and still is, a very, very big part of 2D and 3D video games. And there are a lot of ways to make an animation better and more expressive. And of course, like the IISF technique can be used to also to create your animation and make it better. So that will conclude my presentation for today's workshop regarding introduction to animation. Thank you everyone for tuning in.